Hello everybody, it's Dr. Dave with Physics 152, and I wanted to cover the many right-hand rules that we have been encountering. So, the first right-hand rule I want to cover is the magnetic field due to current in a wire. So what do we have? We have a long straight wire with current I. So right here. So that's my long straight wire, current is running through it. This current I creates a magnetic field. And what we want to understand is how to use the right-hand rule to determine the direction of that field. So what we do in this case is when I have a long straight wire, my thumb is the current, and my fingers are the B field. Just to be clear here, your hand has to be curled. If your hand is flat, this will make no sense. So your fingers tell you the direction that the magnetic field curls around the wire. So again, this magnetic field, which is your thumb pointing that direction, creates your fingers, which are wrapping around like this. Let's look at a side view of that, make sure that we are properly illustrating what we've got going on. So if I were to be standing right here looking at this wire, I would see a current coming right at me. That's the current. And so if my thumb is pointing right towards my face, I see my fingers curling around. The head of my fingers are going this way, and if I continue that motion all the way around, I get a circle. So each one of these is a circle, a field coming out, back in, and back out. Each one of these is a loop. So we only show the dot and the X, but each one is a loop. Okay? And so then what we're saying is we're taking a slice through the plane. We're taking a slice through that plane. And that's what we're showing you right here. So last time again, my thumb is the direction of the current. My fingers, which are curled, is the direction of the B field. If you have trouble with that, just reach out and let us know. The next right-hand rule we're going to look at, and just so we're clear, there are multiple right-hand rules. How do you know which one to use? You have to know context. If that answer doesn't seem helpful, I'm going to just give you a quick review. What is this word? How about this word? How about this word? If you're a native English speaker, you may never have thought about this, right? This first word is tear, or maybe it's tear, wound, or wound, or wind, or wind. Yet if I ask you, which word are they? You'll either pick one, not thinking about the other interpretation, or you would say, can you use it in a sentence? Can you tell me what you mean? So which right-hand rule of the four that I'm going to show you today do you use? You use the one that looks like the setup you're given. So the first one was a long straight wire. Now we're going to look at a loop of wire with current I. So now I have a ring, right, a solenoid or something like that. So I have a loop, and I now have current flowing through it, in this case in a counterclockwise direction. So in this right-hand rule, we do the opposite. Right? Above, my thumb was the current, now my fingers are the current. So we're going to do the opposite. When I have a loop, my fingers are now going to wrap the direction of the loop. So your palm is here and your fingers are wrapping up like that. And your fingers are telling you the direction of the current. Your thumb is telling you the direction of the B field at the center of the loop. So if you do this and we're set your hand on the page, your thumb should be pointing right up at you, which says at the center of this loop, the magnetic field is coming straight up out of the page. Now we have to remember that the magnetic fields always form closed loop. So at some point after they come up, they come back down on the sides. What does that mean? Well, let's now take a look at a side view slice in comparison here. So in this case, I could see the same thing. I could have my fingers be the current, just like we said a minute ago, and my fingers are going to go into the bottom of the page, curl back up out of the top. So my fingers go in here. Oops, sorry. My fingers go in here and they come back out there. And so as my fingers go in here and come back out here, my thumb is pointing this way, meaning at the center of the loop, the B field comes out. But then at some point, the field's got to loop back around to form its closed loops. So that's how we know when my current is the fingers, the B field at the middle is my thumb, that tells me the B field at the middle is coming out. And then we also know the B field outside is going in. All right. Those are the two right-hand rules that we get for when the B field is due to a current, and that's what we're trying to find. There are no forces here, just B field because of current. So now we'll talk about our two right-hand rules that we use when we're trying to determine the force on a moving charge. So we're going to look for force based on the moving V, charge Q. So in our first example, we're going to have a particle moving down the page. We're going to have a magnetic field going to the right. It may be going to the right later, but at this moment it's going to the right now, so that's all we care about. So magnetic field's going to the right. And what are we going to do? We're then going to put our hand in the direction of V. So you might need to turn your page, so this isn't awkward for your wrist or whatever, but your hand is going to go straight down the page. Then you're going to turn your fingers towards B. So if your wrist is here, your fingers are coming down the page, you then turn them in this direction. So you make that cupping motion towards B, and in that case, your thumb comes out of the page towards your face. Let's do one more just to make sure we're super clear, make it a little easier. V is up, and now we're going to make B this way. So now my hand is going straight up the page. I turn my fingers towards B. So my hand is going straight up the page. I turn my fingers towards B, and my thumb is coming out towards my face. Okay. That is now, the thumb is telling me the direction of V cross B. How do I turn that into a force? We remember that force is equal to Q V cross B. So that means if my charge is positive, that my force is going to be out of the page. Again, we're talking in this case here. And if my charge were negative, then my force would be into the page. So a proton moving this direction in this B field would get pushed out of the page. An electron moving this direction in a B field would get pushed into the page. All right. So our fourth right-hand rule that we're going to talk about is the force on a wire with current I. And so now what we have, I want to be super clear about this because this can be very confusing. This current I is not causing the B field represented here. What do I mean by that? Remember here we found the B field due to this current. Now what we're saying instead is the current in this wire, we're going to ask what force is on it because of this B field. This current would also create a B field, but that B field is not being represented here. So what are we asking? We're saying if this external B field exists from some other reason, and I put a wire in it, and that wire is carrying a current I to the left, what direction would the force be? So this one is very similar to the one we just did. Your hand is in the direction of current, which you can think of as the direction of V, like we did here. My hand is in the direction of current, or the direction of V. And so as my hand is pointing in this direction, I then have to turn my fingers towards B. So in this case, my hand is laying flat on the page. I turn my fingers upwards towards B. And when I do that, so then my hand is on the page, pointing to the left, I turn my fingers up, my thumb is pointing in that direction. So now what I have is, that is the direction of force on this wire due to this B field. So hand is direction of I, or velocity of the particles that are moving. Turn your fingers towards B, and that's the direction of force. These are the four right-hand rules that we're expecting you to be able to navigate with. Which right-hand rule do you use when? Well, it depends on the context. If you're asking what the magnetic field is due to a current, you use one of these two magnetic fields. If you're asking what is the direction of force on a moving charge or a current, you use one of these two. Thank you very much. Have a great rest of your day.